Beautiful example or exam question, and we like bringing stuff like this. Okay, so there is just one information, or let me say two information you are given here. One is that you're given two vectors, and they are vectors v and u. And then secondly is that you are told that the length of the vectors are the same, and then you are asked to find the value of alpha that will make that happen. Okay, so for what value of alpha will the length of u be equal to v? So all I need to do is to find the length of u. So what will be the length of u? The length of u, by what we say yesterday, is going to be 3 squared plus what's the coordinate of j here? The coefficient of j there is 1. Okay, so that's going to be 3 squared plus 1 squared. Okay, and that's going to give me square root of 3 squared is 9 and 1 squared is 1. So that's going to be the square root of 10. Okay, so you are not dropping your attendance on this WhatsApp group. Come to the live chat and join the class. You are not, just follow the link. Zeke, you can tag this link there, and don't let them distract you from the class. Please, it's very important. Okay. Okay, so now we have gotten that the length of u is root 10. So let's try to get the length of v. Should I allow you to do that? Okay, the length of v, if you watch, you will see that alpha is missing. Okay, so because alpha is the coordinate of I is missing, and then this one. So that means if you want to write this in bracket form, it will be alpha minus 1, and it is that alpha that we are looking for. Okay, so this is going to be the square root of alpha squared plus the square of minus 1, which is going to give us the square root of alpha squared, and minus 1 squared is 1. Okay, so that means we have gotten the length of v. Sorry, remember to put this absolute value there. Okay, so now so what does that imply? So now from the question, the two lengths are equal. So absolute value of u is equal to absolute value of v. So that means this square root of 10 is equal to the square root of alpha squared plus 1. And what will that do for us? Watch it. So square root will cancel square root, and so you are going to have that 10 is equal to alpha squared plus 1. Okay, so here you can now transfer 1 to this side, and that will give you 9 is equal to alpha squared. Therefore, our alpha is the square root of 9, which will be equal to plus or minus square root of 9. And so your answer is plus 3 or minus 3. Okay? I know that some of you would have thought that the value for alpha will be only 3. No. Whenever you take square root, it's supposed to be plus or minus. The only thing is that, assuming that you are in a case where your alpha cannot be minus, for instance, let's assume that it was log alpha. So of course, log cannot have a negative value, so you will only take 3. So please take note of that. You're already in 200 level, so you will not be doing things that 100 level students are doing. Okay, so that is the value of our alpha. And what information did we use here? We used the information of length and then equality of length. Okay, so that's how this works. All right, so quickly, let's now go on and try to see if there is another example that I would like you to see here. Okay, it's all right. I think this one is enough. If I see another one, of course, in this, I'm using your book and then some past questions. So it will be nice that you are seeing some of these questions. Okay, quickly, let's go over to another thing I want us to start with today. And what is that? That's the concept of unit vectors. Okay, I know I defined unit vectors yesterday, but I think this is a good time to also talk about it. So what is a unit vector? A unit vector is a vector that has magnitude of 1. Okay, so a vector V is unit if the magnitude of V is equal to 1. Okay, so if you determine the magnitude of a vector and it gives you 1, then you call that vector a unit vector. That's actually, okay, let me give examples. Examples of unit vectors. There are what we call standard unit vectors. For instance, I is a standard unit vector, J is a standard unit vector, and K is also a standard unit vector. Okay, so now why is this so? Now, of course, if you remember yesterday, I told you that I in R2 is equal to 1, 0. Okay, so, and in R3 is 1, 0, 0, and so on and so forth. While J, I told you, is 0, 1 under R2, while under R3 is 0, 1, 0. And then K is, okay, we don't have K in R2 because K is the third component, so it cannot be in R2. So in R3, our K is 0, 0, 1. Okay, so let's use this definition to check if what we have said is true. So can we try to determine the magnitude of I? Of course, if you determine the magnitude of I, that's going to be, assuming you are in R2, that's going to be the square root of 1 squared plus 0 squared. Even if you are in R3, that will be another 0. Even if you are in R4, that will be another 0. So no matter the dimension where you are, your square root of, your magnitude of I will always be square root of 1. And that will always give you 1. And that's why we refer to these as standard unit vectors. Okay, now we can see other examples of unit vectors, but that is not why I am here. Why I want us to see unit vectors is that there is one thing we like to bring in exam, and what is that? We call it unit vector in the direction of any vector. Okay, we can give you a vector u that is not a unit vector. For instance, let's say that u is u1, u2. That means it's from R2. Okay, so this one is from R2. I hope you are following me. So as you are following, please, you can be giving your emoji so that I will know that you are with me. Okay, but don't be distracted. Okay, so now yesterday we said that if a vector is in R2, it means it has two components. Now, so let's assume that u is in R2. Now, we can actually say, okay, we don't know whether this vector, in fact, we know that this vector is not a unit vector. And we want to get a unit vector in the direction of this vector. Unit vector in the direction of u. That vector is represented by u caret. It's represented as u caret. Okay, and this is how it is defined. It is defined as u all over the magnitude of u. Very simple. That means I can get the unit vector in the direction of any vector. Another way to say it is that you can get a unit vector that have the same direction with another vector. Okay, so now look at this example. For instance, we are told to find, okay, let me call this example 2 because we have done 1 before. Find a unit vector in the direction of u, and u is given as 4I minus j plus 5k. Okay, so we are asked to find a unit vector in the direction of u, and this is our u here. Okay, so what do? You use the formula. Okay, so and that is going to be, all right, solution. So for this case, u caret, which is the unit vector in the direction of this u, is going to be my u, which is good I put it in bracket form, 4 minus 1 comma 5 all over the magnitude of u, and the magnitude of u is 4 squared, which is 16, plus minus 1 squared, which is 1, plus 5 squared, which is 25, and that is going to give me 4 comma minus 1 comma 5 all over. What is this going to give us? If you sum all of this, you're going to get 42. Am I correct? Yes. Square root of 42. Okay. So the implication of this is that our vector u caret is equal to 4 all over root 42, comma, minus 1 over root 42, comma, 5 all over root 42. You know, by fraction now, this is going to divide everything that is here. Okay, so that's exactly what you expected to do. Okay, so what is it going to be now? So that means that this is our unit vector that is in the direction of u. And like I usually would say, it's important that you always confirm that what you have done is actually true. Now, can we confirm that this is a unit vector? Can we confirm that this is a unit vector? And how do you confirm that something is a unit vector? You do that by taking the magnitude. So if we take the magnitude of this, is it going to be 1? Okay, if what Sir Pressure said is true, then the magnitude of this must be 1. Okay, so let's try to confirm that. Alright, so let's look for the magnitude of u caret, which is going to be the square root of the square of this. So square of 4 all over root 42, then plus the square, okay, you square it, plus the square of minus 1 all over root 42, plus the square of 5 all over root 42. Okay, this is square root we are looking for. So what is that going to be? Okay, Confidence is asking me to explain it again. I will explain it again with probably another example. Okay, I think that will make more sense. Is that okay? Yeah. Okay. Before I come back to this, maybe some of you that followed can continue with this, but let me try to bring confidence to the level where we are. Maybe other people also have issue with it, and I'm going to use a second example. Okay, so let's take it that you have V equal to let me use the normal distance, 4I plus 5I. Okay, sorry, plus 5J. What am I writing? Plus 5J. Okay, we want to find the unit vector in the direction of this vector. So that means we want to find v caret. So what is v caret? We said that it is simply equal to your v all over the magnitude of v. Please, if you have done this and you got 1, please chat in the group and tell us that you got 1. Okay, now let's go on. All right, so we want to get the vector that is a unit in the direction of this, and that is going to be, okay, my v. Meanwhile, you can write this v in bracket form, which is 4, 5, which is 4, 5. All right, so here I'm now going to have 4, 5. Now, why I'm putting it in the bracket form is that it is more convenient to write it in this division. Okay, so all over, what will be the magnitude of v? That will be the square root of 4 squared, which is, this is not the example I wanted. Please permit me to change it. I wanted to get a perfect square. In fact, permit me to change it to minus 3j. Okay, or should I just change it to 3j? Okay, because I wanted to get a perfect square so that it will be much easier for you to get. Okay, so in this case now, my j component will be 3. Okay, so now watch it. So the square of 4 will now be 16 plus the square of 3, which is 9. Okay, so you see what I wanted here. So this is going to give me 4, 3 raised to the, all over the square root of, do I need to write the square root again? Okay, 16 plus 9 is 25, and the square root of 25 is equal to 5. So our v caret is equal to 5 will divide 4 and will also divide 3. So you get 4 over 5, 3 over 5 as your vector. So, and you can write it in ijk form, which will be 4 over 5i plus 3 over 5j. Okay, so any of that. All right, so that's good. Onyi says she got 1. Perpetua got 1. Chidera got 1. I'm not sure I've seen Rita in this class. Okay, I'm not sure. And Evans, have I seen you? I'm not sure. Okay, I'm not have seen Zikora. All right, please, Evans, let me see you so that I will know your YouTube name. Okay. All right. So, confidence. I hope that this made sense now. If it did, please respond so that I will know that you have understood it. Okay. So back to this particular check that we are doing here. We'll also do the check here. Okay. For those of you who have already gotten it, that's very beautiful. So here we are now we want to check if this will give us 1. So if you open this bracket, square will come on 4, and that will give you 16. And all over, square will come on root 42. Square will cancel root and will give you 42. Okay, Fidelis, that's good. So you also do here, minus 1 squared is 1. All over, square of 42, root 42 is still 42. Plus the square of 5 is 25. All over 42. So you see that you get the square root of the LCM will be 42. If you add 16 plus 1 plus 25, and that is going to definitely give you 42 over 42, which is equal to square root of 1, and that is equal to 1. So definitely you will get 1. All right, confidence, that's beautiful. Okay, so we can now progress. So I said to show you this concept because it's important. We bring this one every other year. So this is example 3, and I'm going to allow you to do it. It says find the unit vector in the direction of this vector. Let me call it W, and they gave us W. Okay. No. All right. Okay, let me just give you any example here. Let's say you have minus 5, 5. Okay, find the unit vector that is in the direction of this vector. You can put it in okay, let me change the example. Let me adjust the example a little. Okay, so let's take it that you have something like minus 8,6. Minus 8,6. Quickly do advanced assistant is writing the attendance. It's okay. All right, so help me get the vector that is the unit vector that is in direction of W. Everyone, that means you're looking for W carat. Everyone, I'm waiting for you. Okay, so do we have responses? Do we have responses? We'll try to be very faster today so that we can also reach more grounds. It's very important. But you see exercises. The only way I can be sure that you are following me is that we do exercises. And I will keep giving you. Okay? Chidera Joyce is here. Okay, yeah, Rita, I've seen your comments. Okay. Alright, Miracle. Okay, you are there. Okay, says thank you. You're welcome. All right. Okay. Who else? I've only received a response from Chidera. Okay, Onyinye. More responses. All right. Because of our time, we can make do with those two because two of them are correct. So definitely you are going to get minus 4 over 5, comma 3 all over 5. How? Because let's do it together. Our W carat is going to be W all over magnitude of W, and of course our W is minus 8,6 all over, and then magnitude of diamond, I can see your response. Magnitude of W will be minus 8 squared, which is 64, plus 6 squared, which is 36, and this is going to give us minus 8 comma all over square root of 100, which is 10, and so you will get minus 8 over 10 or comma 6 over 10, and of course this is equal to minus 4 over 5 comma 3 all over 5. All right, so that's very beautiful. Zikora Florence, you're welcome. Zik, like I said, please don't let the attendance distract you. Let it not be that you're doing attendance and you're not responding to me fast. Okay, so quickly, let's move to something else. And what is that thing I want us to look at? I'm going to bring it in form of an example. It comes from where we stopped yesterday, where we talked about vectors in A, B, B, C, and the rest of that. That's representing vectors as line segments. Now, it's important that we also see vectors as a line segment joining 2 points. Okay, look at this particular example. Maybe you can title these vectors as line segments. So that you can know what you're writing in your notes. Okay, all right, so look at this example here. Now here we are asked to find Find the vector represented by the line segment AB. You know, you can put a line on top of it or you can leave it. Given that A, okay, number 1, you are told that A is 2,6, and then your B is minus 4,1. All right, and then your B is maybe I'll just take 2 examples, or I'll write 3, but I'll just take 2 and then you take 1, or I'll make it up to 4 depending on what I have. Okay, this is comma 3, and our B is minus 5 minus 6. Okay, let's say C is A 1 minus 3 comma 6, and B is 0 1 4, and then let D be A 1 0 1, and your B is equal to 7 minus 1 and 6. I'm going to show you why I decided to bring these examples. Okay, so let's go on. Now, watch what we are given here. We are asked to find the line segment. That's the vector that is represented. Oh, find the vector. I omitted it here. Find the vector that is represented by the line segment AB. Now, what we mean by line segment? Of course, you can see that all these things are points. Okay, so all of these are points that we can plot on a Cartesian plane. That's for AB. We can plot A and B in a Cartesian plane because they are 2 coordinates. Okay, so it means that, for instance, my point A is is point 2, 6, and let's be that point B. I'm just giving an example. Of course, you know this is not correct. Point B is minus 4 1, because minus 4 should be the other way. Okay, so this is point A and this is point B. You know how you did physics, so you will join the 2 points and then it will form the vector AB. Okay, so that's what we are saying. So we are asking you to find the vector that is represented by these 2 points. Okay, so how do you find vectors represented by points like this? Very simple. For the first one, remember I said I will do only 2. For the first one, my A, our AB, the vector AB is going to be equal to, now all you need to do, your AB is always equal to point B minus point A. So if I give you 2 points X, Y, and ask you to, if I give you point X and Y and ask you to get vector XY, your vector XY is simply equal to Y minus X. The last point minus the first point. That's all. And we have already done subtraction of vectors. So that means our AB in number A is going to be minus 4, 1 minus 2, 6. And that is going to give us minus 4 minus 2 will be minus 6, 1 minus 6 will be minus 5. Therefore, the vector we are looking for there is equal to minus 6i minus 5j. And that is your solution. If you followed me to this point, please give a thumbs up to that. And then I will go over to example 2. Okay, of course, I'm not going to do example 2. You will be the one who will do example 2 by yourself. Okay, so If you followed me, you give some thumbs up and quickly get vector AB for me for example B. And then we will, okay, or should I do example C first? Okay, so let's go to example C. All right, so our example C is minus 1, 1 minus 3, blah, 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 if I can remember that. Okay, so let's go. So we have here point A is, this one now is 3 coordinates. All right, so it's 1 minus 3 and then 6. And our B is on a point 0, 1, and then 4. So that means that my vector AB is going to be equal to B minus A. So I can quickly do it. 0 minus 1 is minus 1. 1 minus minus 3 will give me 1 plus 3, which is 4. And 4 minus 6 will give me minus 2. Therefore, my vector is minus I plus 4j minus 2k. And that is the solution. All right. So now we are done with A and C. I want you to do B and D quickly. You can do it together and submit your solution now as a comment, everybody. I also give you only 30 seconds to do that. It's not a big deal. Okay, Precious, which one did you do? I said you should always number the one you did. Okay, B, all right. Okay, B. Okay, Precious, Chidera, two responses. Confidence, yeah. After your thumbs up, please do, and then let me see your answer. Okay, let me go back to that page for some people that want to see it. Okay, sorry about that. Page, see it. B is 0, 3 minus 5 minus 6. Maybe I should bring it here. Okay. A is 0, 3, while our B is minus 5 minus 6. And then our D is 0, 1, 0. What again? 7 minus 1, 6. Okay. Sorry about that, Daniel. Okay, see it here. This is our B. And then this is our D. Okay, so you can go on and, okay, Chidimma. Okay. Alright, so I'm seeing minus 5 minus 9 as the answer for B. Okay. Alright, Favor. Okay, straight away to D. D now. D. Please ensure that you're doing what we are doing. You are only going to know that you are getting it by doing it. You are only going to know that you're getting it by doing it. Please remember the first thing I said on the pinned chat. When you join, please do subscribe to the channel and give a thumbs up to this video as we are live. Okay, so it's important for the algorithm of the video. Okay, so Precious also has for D. Okay, you didn't see it clearly. Which one? Chidera, Rita. I said that B is A 0,3, while the B of that the point B is minus 5 minus 6. Okay, and then the D, A is 1, 0, 1, while B is 7 minus 1 and then 6 over. Okay, let me go to the next page and write it again. Okay, see your B here, and then D is A is 101 and B is 7 minus 1 6. Okay, for Jessica, I hope you can see it now. Okay, Chidera, you have 5 and minus 9. Are you sure it's 5 and minus 9, or minus 9 and minus 5 and minus 9? Look at it again. Rita, I'm referring to you. Okay, so quickly, maybe we can move on here. So in this place, our AB is going to be, remember what I said yesterday, if your red line is behind, drag it to the front so that you will follow us. Okay, so our AB for the B is going to be minus 5 minus 0 is minus 5, and then minus 6 minus 3 will be minus 9. Okay, while for example D, okay, I've seen responses. All right, let's see. Our D is going to be, AB is going to be equal to 7 minus 1 is 6, minus 1 minus 0 is minus 1, and 6 minus 1 is 5. Okay, so let me see some of the options we got. Okay, where are they? I think I first got from Chidinma. So, okay, so from Precious, 6I minus J plus 5K. That's beautiful. Who again? Okay, Daniel, correct. Raluchuku, correct. Inyolua, correct. Chidinma, correct. Chisom Mordecai, is it plus 1 or minus 1? Please check that and make the correction. Ezigwe favor, that's beautiful. Okay, so now we can go on. Now let's look at this example, which is another reason why I came to this particular point. Meanwhile, we also bring all of these regularly in exam. Now see what this question says. Find the distance. Or let's put it that way. Find the distance between A and B, where our A for I is equal to, our A is equal to 10 comma minus 3. Okay, distance between points. We have actually done this one. In fact, that's not the way I wanted to ask this question. Okay, let me put it this way. Find the length or the magnitude. Let's put it that way. Find the magnitude of AB if, okay, we have A is 10 comma minus 3 and B is minus 1 minus 5. Okay, let me just give two examples here. The second one is A is 0 minus 5 and 2, and then the second one your B is minus 4 minus 1 and 8. Okay, so let's go ahead. All right, so what does that mean? So this question now is asking us to get the magnitude of vector AB if point A is this and point B is this. All right, so in other words, this person is asking you to do what you have done here. Get the vector AB first and then look for its magnitude. All right, so and what is that going to be? So for I, our AB is going to be equal to you are going to have B minus A, so it's going to be equal to minus 1 minus 10, which is minus 11, and minus 5 minus 2, minus 5 minus 3, That's going to give us minus 2. So we have gotten the AB for example I. And so this magnitude of AB here is just going to be what we have already done. The square root of minus 11 squared, which is 121, plus the square of minus 2, which is 4. Okay, and this is going to give us the square root of 125. And that is the solution. Okay, so I hope you followed that one. If you followed it, everybody get me the solution for II. What is the magnitude of AB in II? You have 1 minute to do that. Is it up to 1 minute? 30 seconds, you should be able to finish it. Quickly, everyone. Alright, Fidelis, I've seen your response. Sylvia, Christy, Blossom, okay, and then the rest of that. Chisom, that was good. You have corrected that mistake. Okay. Okay, so quickly, I here, what's going to be the magnitude of AB in II? What will be the magnitude of AB in II? So the first example is not clear from Chris. Okay, there is nothing hidden here. What we are saying is that we are asked to find the magnitude of AB, and they gave you point A and B. So for you to get the magnitude of AB, you need to first of all get the vector AB. Alright, and which is what I taught you here. This is what I've always been saying in this class, that when it comes to our exams, we don't just come and ask you find vector AB if point A is this and point B. We also ask that question, but most of the times what we will usually do is to ask you a question that will make you do that thing that we would have liked you to do. Okay, so here now, this person have asked you to find the magnitude of AB, and then he gave you point AB. That's because he knows that you will need to get the vector AB first. So all you need to do here is to get the vector AB first, then you now take the magnitude. You already know how to get magnitude, and you already know how to get the vector. So there is nothing more hidden here. So how do you get the vector? To get AB, I said you should do B minus A. To get XY, do Y minus X. To get CD, do D minus C. So here now, I did B minus A. And how? Minus 1, you do it component wise. The first component we subtract the first component, the second component, the second component. That's what we did yesterday. Okay, so if you do minus 1 minus 10, you get minus 11. And if you do minus 5 minus 3, is that what is confusing? You see it now. Minus 5 minus 3. That's going to give you minus 5 plus 3. And minus 5 plus 3 is minus 2. That's how I got minus 2 here. Okay. So, and the magnitude of this is the square root of the sum of their squares. What is the square of minus 11? Is 121. What is the square of 2? Is 4. So if you add this, you get square root of 125. That's how I got it. Okay, Chris, I hope it made sense now. If it did, if it's clearer now, you can let me know, and then you can do what we have. Okay, so Inyolua is getting root 68, while people up are getting root 88. Favor down now is getting 88. Sylvia 88. Chuku Daniel 68. Okay, so let's do it together. Let's see where the discrepancy is coming from, because it has to be the same answer. All right, and those of you who did whatever, you can check. Okay, Chris, you're welcome. All right, so let's try to get AB for example 2. So what will our AB what is it going to be? So here we are doing b minus a. So b minus a is going to be minus 4 minus 0, which is minus 4, minus 1 minus 5, which is going to be minus 1 plus 5, and that is plus 4, comma, here we now have 8 minus 2, which will give us 6. All right, so the magnitude of this now is going to be equal to the square root of the square of minus 4 is 16, plus the square of 4 is also 16, plus the square of 16 is 36. So here you have the square root of 16 plus 16 is 32, and 32 plus 36 will give us 68. And so our answer is root 68. So I want to believe that for those of us that got 88, the reason is because you probably did not add well. You probably did not add well. So that's why you didn't get the same answer. Please ensure that you do your addition well. Maybe all this minus, I know that's why. Okay, minus 1 minus 5 is going to be minus 1. Minus is plus, and so it will give you plus 5, and minus 1 plus 5 is equal to 4. Maybe that's where the error came in. All right, so and immediately we can now begin to move forward to other things that we need to discuss today. Okay, so at this point we now start looking at dot product. So let's begin to look at the concept of dot product. Okay, so because we have seen vectors, we have seen some algebra of vectors. When it comes to linear combination is actually talking about addition and subtraction of vectors. Okay, addition and subtraction of vectors. All right, for instance, let me just give one example under linear combination. Of course, we have been doing it, but let me just bring in this one. So it's just addition and subtraction. That's the meaning of linear combination. Which one did you get? Root 133. Usamaka. Please, so let's check it very well. Okay, so look at this example here. It says that our u is given as, let me write, okay, let u be equal to 1 1 1, comma, w of v, is equal to minus 1 3 and 2, and then w is equal to minus 3 0 and 1. Okay, so the question now says express 3u minus 4v plus 2w as a linear combination. As a linear combination of, you can say, of ijk if you want. So now this is actually a linear combination of these three. So linear combination means joining two or more vectors with addition and subtraction and scalar multiplication. And that reminds me, what is scalar multiplication? We didn't do any scalar multiplication yesterday. Scalar multiplication is using a number to multiply a vector. For example, now, from here now, 3u simply means 3 times this vector u, 1 1 1, which is simply going to be 3. We open the bracket, so you get 3 3 3. All right, so while minus 4, or let me just write it as 4v. So our 4v is equal to 4 times minus 1, 3, and 2. And that is going to give us minus 4. 3 times 4 is 12, and 4 times 2 is 8. Then finally 2w is equal to, here we will have 2 times your w is minus 3, 0, and 1, and that is going to give us minus 2 times minus 3 is minus 6, then 0, and then 2. Okay, so this is what we call scalar multiplication, using a number to multiply a vector. Okay, so now when you join scalar multiplication and the addition and subtraction, you will now get what we call linear combination. So, or you can easily just say the addition and subtraction of vectors. That's what gives us linear combination. So in other words, our 3u minus 4v plus 2w is going to be equal to, so we are just going to add all these ones. So that's going to be 3, 3, 3 minus our 4v is minus 4, 12, 8, and then plus our 2w is equal to minus 6, 0, and 2. It didn't enter the same line, so that's why I came down, and that's going to give us, so you are still going to do it component wise. You start with the first component. 3 minus minus 4 is going to be 3 plus 4. Then that is 7 now. Then you now say 7 plus minus 6. Plus minus is minus. So you get 7 minus 6, which will give us 1. And comma, you go to the second component. You will do 3 minus 12 is minus 9. Then you will now do minus 9 plus 0. And that will give you minus 9. So you have minus 9 here. Then comma, finally, you will now do 3 minus 8 is minus 5. And then you do minus 5 plus 2. Minus 5 plus 2, that will give us minus 3. And that is the solution. Remember that this thing is 1, no, not 7. Okay, please, if you understood what I explained now about this, you can let me know in the comment section or with any emoji. And so we will move to the next thing. Goodness God, I will need to rest more. Do I have to? Okay. Okay, so now I want us to begin to look at the concept of dot product. The concept of dot product. Okay, understood. Thank you, Jessica. Understood. Who else? Okay, please respond. Respond. Okay, so that I can know that I'm moving on. All right, beautiful, beautiful, beautiful. Okay, so let's go to the next concept that we have. Okay, so I'm happy that we are introducing dot product today because it's important. Okay, so dot product of vectors. Now remember I told you yesterday that there are other names for dot product. Okay, one of it is what we call, you can call it scalar product. Scalar product is different from scalar multiplication, and you can also call it inner product. Okay, any of these three names. All right, now scalar multiplication is what I just did before, where you multiply a number, a vector by a number. But scalar product is now what we are going to do. So the difference is the name, product multiplication. All right, please take note of that so that you don't confuse yourself with the names. All right, so let's go on. Now, how do we take dot product of two vectors? Okay, so first of all, you should note that dot product only happens for vectors of the same dimension. Okay, so dot product, let me write it, is only defined, dot product is defined for vectors of the same dimension, vectors of the same dimension. And that this is why I said yesterday that people should watch the video if they did not join the class. For instance, now, what is the meaning of dimension? Which one did you not understand, Chisom? Please try to take your red line to the end so that you will be responding when others are responding. Okay, which one did you not understand? Is it the what do you call it, the linear combination? Okay, when I said linear combination, see what I am talking about. I said that you can be given vectors and then you are asked to get something like the one I did before. Let me do something like this. Maybe we ask you to get u plus 2v minus w. This is a linear combination of u, v, and w. Okay, so another example is I can give you something like maybe 2u plus w, something like this. This one now is a linear combination of u and w. So what did I say is linear combination? I said is the addition and subtraction of vectors, together with some scalar multiplication. Okay, so look at it now. For example, this b now, if I want to do b, 2u plus w is going to be equal to 2 times my u, then plus my w, and my w is minus 301. Okay, so please, what's the name again now? Rita, sorry about your network. Chisom Mordecai. As I'm explaining, at any point where you understand me, you let me know. Okay, so this is now going to be equal to, all you need to do is do the scalar multiplication, which is open the bracket, and if you open the bracket here, you are going to have 2, 2, 2. Then plus, here is still minus 301. Okay, so which is now going to be, just add what you have. And if I add, you are going to add component wise. I've been saying this since yesterday. First component will add to first component. So 2 plus minus 3. I think the problem here is sign. Okay, and we should be able to handle issue of signs. It shouldn't be a problem. Okay, so all right, what do you have here? 2 plus minus 3. Plus minus is minus, so that will give you 2 minus 3, which is equal to minus 1, comma. You come to the second component. 2 plus 0 is 2, comma. The third one, 2 plus 1 is 3. And you are done. This is your answer. Okay, I hope that you've understood it now, Chisom. Okay, so let's go on to where we are under dot product. Okay, so for this dot product, the first thing I said is that you can only define a dot product for vectors that have the same dimension. And what is the meaning of dimension? We discussed that yesterday. That dimension means the number of components in a vector. For example, this vector now is 3 dimension. This one now is where is, okay, 2 dimension. You know all of that. Let me not bother you with that again. Okay, so now let's do the definition. So assuming that you have 2 vectors u and v, okay, dot product is defined, their dot product, their dot, what is that? Their dot product, okay, given as u dot v is defined like this. Okay, so this is how you define dot product. U dot V is equal to, okay, meanwhile, let me explain what our U is. Our U is, if I use 3 components or 2 components, or let me use, okay, let's use 2 components. U is U1 comma U2. So if U is 2 components, okay, Chisom, that's okay. So if U is 2 component, that means V must also be 2 component. That means V is V1, V2. Okay, so now your dot product is going to be equal to, you are going to have the first component of U will multiply, we multiply the first component of V, and then the second component will multiply the second component. You will be adding it. So U2 will multiply V2. If they have a third component, you will multiply them. If they have fourth component, you keep multiplying and be adding until you get to the last component. Okay, I hope everybody understood what I said now. We are going to back it up with examples. Okay, so if you have 2 vectors U and V of n components, their dot product is just multiply each component, corresponding component, and keep adding until you get to the last. All right, so let's begin with examples. Okay, so for here, let's say example 1. Okay, let me remove this and then put it this way. Okay, find the dot product. Find, or let me put it this way. Find U dot V for the following. Find U dot V for the following. Okay, so we are looking for the dot product of the following vectors. Number 1, assume that your U is equal to minus 1 comma 2, and my V is equal to 6 comma 7. Number 2, assume that your U is equal to 2I minus 3J minus let's say K, and your V is equal to minus I plus 4J minus 3K. Okay, so maybe we can do with these 2 examples. All right, so solution, what are we expected to do here? They're asking us to find the dot product. Okay, so for number 1, the dot product of U and V is simply going to be, you pick your U1, which is the first component, that's minus 1 times the V1, which is 6, then plus you pick the U2, which is 2, multiplied by your V2, which is 7. There is nothing difficult here. It's very simple. And funny enough, this is what usually will fill the whole of the exam of 201. All these preliminary places that we are discussing, it's majorly vector and vector algebra. And then we will now touch a little on systems of equation and a little on matrices, which we are going to touch all of that. Okay, so your answer now is minus 1 times 6 is minus 6, plus 2 times 7 is 14. And so you have, your answer is 8. Okay, so I want you to note one thing, that your dot product is always a scalar quantity. What is a scalar quantity? A scalar quantity is just your number. It just gives you a number. One of you asked me a question last night about magnitude of a vector. That's also another scalar quantity. If you check, whenever we do the the magnitude of a vector, we always will get a number. So that's because it is a scalar quantity. So your dot product is a scalar quantity. Your vector product is a scalar quantity. Please, like we said yesterday, I'm already seeing people touching some emojis. Once we explain a new thing and you followed, please, you should signify by giving some emojis. All right, so that's just your dot product. Nothing serious. Nothing serious. And example 2, what are we going to have? Our u dot v. And this is the most important reason why I taught you how to write all of these vectors in bracket form. So because under dot product, it will be helping you, even though you can still do it whether you put it in bracket form or not, because here you can clearly see the coefficients. Okay, so the coefficient of here is of I is 2, of j is minus 3, of k is minus 1. If you come to your v, the coefficient of I is minus 1, of j is 4, of k is minus 3. So it's already in bracket form. So my dot product, which is equal to minus 2, do I need to write that again? No need. Let's just go ahead and do it. Okay, so you are going to have the first component here will times the first component. So this is minus 1. It is always addition. Then you have plus minus 3. Now, like I said, it's always addition, but this one now is minus. So that means I'm going to have plus minus. So this minus will swallow this plus. Of course, you know that plus minus is minus. Okay, all right, beautiful. Somebody has already given us answer for number 2. That's what I expect from us. In fact, I wanted to ask you to do it, but I'm already doing it, and I'm going to give you another one. Okay, so Jessica, thank you very, very much. Okay, so here is now going to be minus 3 times 4, and the last one will also be minus 1 times minus 3. Why? Because this minus will swallow the addition. Okay, so this is going to give us 2 times minus 1 is minus 2. So we are trying to catch up with Jessica now. You know, she's before us. Chidinma says minus 11. Favor says minus 11. Let's see. Okay, so the next one is minus 3 times 4, which is minus 12. And then the next one is minus 1 times minus 3, which will give us plus 3. Okay, and what's that going to be? Minus 2 minus 12 is minus 14. And minus 14 plus 3 is minus 11. Okay, we ended up catching up with Chidinma, Jessica, Blossom, Chisom, and Chidera. Okay, so if you didn't get minus 11, check where you made the mistake. It must be on the sign. It must be on the sign. And don't let the sign confuse you. What I explained here should be able to help you. Whenever you're writing it, it's always a plus. But if you want to write minus attached together with plus, minus will always cancel out plus to give you minus. Okay, did you get that? All right, so let me give another example, and I am sure everybody will get this one. Everybody. Okay, so let's see. Let me see if I can get. Okay, look at this one. Example 3. You are to take the dot product of this u. Here our u is okay, let me put it in ijk form. Is 2i minus 3j plus 2k, and our v is equal to 3i plus 5j then minus 4k. Everybody quickly. In fact, as I'm dropping it, I expect answers already. Okay, let me still go down and try to give another one. All right, okay, let's see this one. Here v is equal to I plus 6j minus 2k, and our u here is equal to I don't want to use this 2i again. Okay, our u is equal to minus I minus 2j plus 2k. Somebody will say, why is our press giving minus? If you don't do difficult examples here, don't bother. When you see it in exam, it will be a problem. So That's why I start by giving you simple examples, and then I push you further to do something that will be more challenging. Okay, so I'm waiting for these two answers. You're getting u dot v, the dot product of u and v. Meanwhile, as you're doing it, please note that, of course, that's one of the deductions that we are going to do here. You are going to see that u dot v is actually the same thing as v dot u. We call it the property of commutativity of dot product. So dot product is always commutative. That means you can turn it the same way you can say a plus b is equal to b plus a. The same thing happens for dot product. But if you go to cross product, we will get to cross product maybe tomorrow. That one is written like this: u cross v. First of all, quantity. Remember I said that dot product is a scalar quantity. Here is a vector quantity. You are going to discover that u cross v is not equal to v cross u. We are going to see it tomorrow. But for today, note that any one of these is the same. So if I ask you to take u dot v, even if you do v dot u, your answer will be the same. Alright, so I'm waiting for responses. I'm beginning to see. Okay, so I'm beginning to see some responses here. Alright, who and who now? Okay, Chidimma has minus 17. Joyce, Chidera minus 17. Precious, you're getting 11 for example 2 above. Or is it 3? You're writing 3 minus 11. Okay, no problem. Blossom has minus 17. Daniel minus 17. Christy, alright. Pascal, okay. Pascal, that's good. I like that. Oni, so almost everybody is turning out minus 17. Go to example 4. Quickly, example 4. Okay. While you are going there, let me check through and know if minus 17 is correct. Okay. So let me be doing that on my board also. Okay. And I'm not doing it for anybody. So me, I'm doing my own. You are doing your own. Okay. So let's be doing your own. So here I have u dot v is going to be equal to 2 into 3. In fact, let me be cutting this thing. 6 minus 3 into 5 will give me minus 15, and 2 into minus 4 will give me minus 8. Okay, so this is going to be minus 9 minus 8, which is minus 17. Absolute. Very beautiful. There, you see this my class here. Oh, Jesus. This is my class. You see, when anyway, some of you tomorrow will become teachers. You may not become teachers, but you definitely teach, maybe as a youth corper. Okay, so you discover that one of the joy of a teacher is that the student does well. Some of you come to class and you are not friends to lecturers. Don't do it with me. Be friends with me. The reason is because the most important joy for me is your success. And so some of you think that lecturers want you to fail. If there is any lecturer that does that, I don't. Okay, so I said it yesterday, I want you to get the best. And so when I see you responding like this to whatever I teach you, it gives joy. So I appreciate it. Okay, I'm beginning to see responses. Okay, maybe I should be the one giving you emojis now. So take my love emojis for all of you. So I'm beginning to see responses for exam. Alright, so somebody says 4. Chidimma, this 4 you wrote here, is it the 4 or you made a mistake in writing 4 there? So you are saying 4 is still minus 17. Onyi still says minus 17. Chidera Joyce minus 17. Jessica minus 17. Okay, I wish that you can use voice note on this chat. Jessica, I would have loved you to pronounce this your second name. Is it Dimfna? I don't understand. Maybe you do it on WhatsApp later. Okay, so Ezigwe says minus 17. Dan is saying minus 13. Dan, you are the only one coming different here. Please confirm. Okay, now let's do it together, everybody now. So for number 4, we are doing number 4 together. Okay, so our u dot v is going to be equal to minus 1 is here. The component of I here is positive 1. So I'll pick 1 times I here, which is minus 1. Then plus here I pick 6 times minus 2. And finally I pick minus 2 times my 2. Alright? And that is it. So 1 times minus 1 is minus 1. 6 times minus 2 is minus 12. And this times this is minus 4. Wow, it's true. It's the same thing. Minus 17. Wow, this is beautiful. Minus 17. Okay? So that is that about dot product. So there is nothing serious about dot product. Don't let anybody make you think that mass 201 is something that cannot be done. Is a lie. Don't mind them. 201 is very, very simple. Okay, so let's look at some of the properties of dot product. I have already mentioned one. And why am I looking at these properties? Because in some cases you are going to need it. Okay, so some properties of dot product should I? Okay, the one I mentioned is enough. There's some properties there. I've mentioned only one. I think it's enough for you that u dot v is equal to v dot u. Okay, now let me try to mention another one. Okay, another property you should see is that you can actually do u dot u is the same thing as the magnitude of u raised to power 2. Okay, so if you take I think I like this one. So if you are given a vector u and is equal to, let's say this one I have here, my 1, 6 and minus 2. So we are saying this second property is saying that if you take the dot product of u on itself, that is equal to the magnitude of u raised to power 2. Let's try that. Okay, let's do the dot product of u on itself. That's going to be 1 times 1 plus 6 times 6 minus 2 times minus 2. So the first component will multiply itself, second component will multiply itself, third component will multiply itself. That's going to give us 1 plus 36 plus 4. And that is equal to, this will give you 41. Okay, so what this condition is saying is that if we take the magnitude of this same u and square it, that is going to be the same. What is the magnitude of u? That's going to be the square root of 1 squared, which is 1, plus 6 squared, which is 36, plus minus 2 squared, which is 4. Okay, and this is going to give us the square root of 41. Okay, so you can see now, if you square this thing now, that's going to be the square of the square root of 41. And of course, this will give you 41. See here, math is more beautiful than you think. It is, for me, I think it is just your commitment that has made you think. That's if you are the type that you don't like math. But I want you to start liking it from 201. So I think these two properties are enough because of course they are very beautiful properties. So one is that you can do commutativity. So let me write it here for those of you who want to write what I just said. Okay, so we call this commutativity. Okay, so we say that that dot product is commutative. Some can use O here, some can use U. So dot product is commutative. All right, and then does this have a name? Okay, let me leave that one. So you say that dot product is commutative. I love all those emojis you are giving. All right, let's now go on. Now, after discussing dot product, there is a concept that is so important that you see, and that is what we call orthogonal vectors. Orthogonal vectors. Okay, before I go to orthogonal vectors, I almost forgot. Oh my God. there is another definition for for dot product. Please, very important. Oh, how did I forget that? Okay, so we define dot product here as this. All right. Now there is a second definition. You can call this as definition A. Now there is a second definition for dot product, and that definition is very, very important. In fact, that's what we need to talk about orthogonal vectors. Okay, let me call it definition B. So now the first definition happens, thank you very much everyone. So the first definition happens when your vectors are given in the dimensional form. So when I have my u as a u1, u2 up to un, so I will use the first definition where my v is v1, v2 up to vn. I like that. Okay, so it means we are following. Now, but the second definition, it is possible you can be given, remember yesterday we said that you can represent vectors with line segments. That's diagrammatically. You can write vectors as a diagram. Okay, so now when you are given vectors in diagram form, for you to determine their dot product, first of all, they must meet at a point. Okay, so let's assume that this is vector u and this is vector v, and they met at a point. Okay, so let's call the angle at their meeting point angle theta. Okay, so here now we define a geometric definition for dot product, and we write it this way. So we say that u dot v is simply equal to the magnitude of u times the magnitude of v, and then times the cos of your theta. Pay attention, it is not difficult, nothing serious there. So magnitude of v multiplied by magnitude of u, all multiplied again by cos theta, where theta is the angle between u and v. Okay, so I'm trying to get a very beautiful example that we are going to use to show this. Okay, all right, so look at this example. Okay, so now what exactly do we do with this? Basically, when it comes to this type, we can ask you for many things. We can actually say, okay, we can give you two vectors and ask you to find the angle between them. So to do that, you need this formula. All right, that's actually where we are going to start with. Okay, or maybe let me give you this example first. Okay, let the magnitude of u be equal to 3, and the magnitude of v be equal to 5. Find u dot v if the angle between them is let's say 60 degrees. Okay, so this is a beautiful example. For instance, if you come to exam and you see this example, what do you think you're going to do? You will discover that the first definition I gave you will not help you in getting u dot v. Of course, that you don't even know the vectors. They didn't give you the vectors. They only gave you the magnitude of the vector straight. Okay, and they are asking you to get the dot product of the vector. Okay, so how do you do that? You just use this formula. So your solution is very simple. So my u dot v is equal to magnitude of u times magnitude of v times cos of theta. Thank you, I like that. It means we are following. So magnitude of u is 3 times the magnitude of v, which is 5, multiplied by cos of 60. My theta here is 60. And you are done. What is the answer for this? 15 times cos of theta is half. That's 0.5. So that's going to give you 7.5 as your solution. This is so amazing. All right, so that's how to handle this. Now let's now begin to see, for instance, if we want you to get the angle, how do we bring the question? Now look at this example here. It says find the angle find the angle between these vectors in R3. Okay, this is what they said. Now already anybody that was in this class yesterday and has followed me today, you already know the meaning of a vector being in R3. That means it's going to have 3 components. So look at the vectors here. U is equal to 4i plus 2j minus 2k. It is not 2k, okay, 2000. And then V is giving us I plus j plus 3k. Okay, at this point I'm not sure we are supposed to still be accepting attendance. Somebody cannot be joining the class almost 20 minutes to the end of the class and be writing name here, except you had issues with your network. But if you did not, if it was a physical class, you cannot be joining the class now and be writing attendance. In fact, I wouldn't have even allowed you to join my class by this time. So please, like I said yesterday, handle whatever I'm doing for you here as very serious as it is. Note that there is nothing we have done here that we are going to repeat even when we come back. Maybe we start from next week or so. We are not going to be repeating. This is our normal class. All right. And in fact, geology has been telling me that the class has been clashing. So that means maybe even by next week we can even continue here, and then so that everybody will follow. Because all this while I come to class and somebody is using hall, we are dragging hall and all those nonsense. And then many other times you people didn't even show up. And then later Evans told me that your classes have been clashing. So I don't know why people will not take this serious. I understand some persons chatted me and said that they are on the road and all that. So there is no problem. Those ones can come back and watch what we have done. But if you are available, why not be part of the class? Why join the class by this time? I don't think it's very nice. I'm just trying to say. Okay, let's go on with what we have. So by now, yes, Rita, I think it does. It does. It does. It has a manual. Okay, so maybe they will announce that later. I even have a copy of it here. I'll snap it and show you. It has. All right. So let's go on. Look at the question we have here. I think some people should have tried doing it by now. So here we are told to find the angle between these two vectors. Okay. So the only formula we know that connects to angle for now is the dot product. The cross product also connects to angle. You're going to see it when we get there. So what are we going to do? We'll start by writing the formula u dot v is actually equal to the magnitude of u times the magnitude of v times the cos of theta. So where theta is the angle between them. Okay? So in other words, all my job here is to make theta the subject. So, and I can do that by dividing both sides by magnitude of u and magnitude of v if I want. Or I can just substitute and then divide later. But I'm already doing it. Okay, so if I do this, the whole of this will go. So that means my cos theta will now be equal to u dot v all over magnitude of u times magnitude of v. And you are done. So all you need to do here is the is it because of the manual? Okay. Anyway, let me not talk about it. So here now we need to get our u dot v. So what is our u dot v? Everybody help me do that. U dot v You get your u dot v, get your magnitude of u, get your magnitude of v, and then we substitute. I'm waiting. What is u dot v? Chris, is not hard. It's not true. Chris, is not hard though. It's not hard, Chris. Just pay attention. As we go on, you are going to get it very well. And what is here? I'm still waiting for angle, okay? How is it hard? Yes, it's not hard. There is nothing here, okay? You are given two vectors, and they ask you to get the angle between them. You use the formula. The formula that gives you angle connection is u dot v is equal to magnitude of u times magnitude of v times, and all you need to do is to get your u dot v, get magnitude of u, get magnitude of v, then substitute and then make theta the subject. There is nothing more serious there. So did anybody get u dot v? Nobody is responding to me. Okay, let me do it myself then. So my u dot v is going to be 4, maybe I should do it here. U dot v will be equal to 4 times 1. The component of I there is 1. Then plus 2 times 1 also. Okay, somebody got 0. Beautiful. And then minus 2. Let me finish my own. Minus 2 times 3. That is beautiful. That's done. Okay. Okay, did any other person do it? Let's confirm, although I'm already on it. So this will give us 2 plus 2 minus 6, which is 0. Oh, wow. This is amazing. So you are going to have 0 all over. And you see the beauty now. Since our numerator is 0, do we need to get the denominator? Let me hear you answer. Do you need to get the denominator? The answer is no. Assuming this was the exam, you have jumped that step. Because since the numerator is 0, whatever is the denominator, you will still get your answer to be what? 0. And so, what it means is that our u dot v is 0. Let me even remove this place. I don't need it. Okay, so I have gotten my u dot v. So I don't need to get the denominator. So what it means is that my cos theta is equal to 0. So how do you get your theta now? Your theta is simply equal to, take the cosine to the other side. That will give you cos inverse of 0. And what is cos inverse of 0? What's cos inverse of 0? So you use your calculator. Of course, in exam, we allow you to use calculator. I know some of you will want to ask me. Yes, we will allow you to use calculator in exam. Help me with the cos inverse of 0. Cos inverse of 0. Who is doing it? I'm just allowing you to do it. It's not as though I cannot tell you even without using a calculator. So I'm just trying to let you get involved. The cos inverse of 0 is equal to what? Okay, Joyce, thank you. Thank you very much. Okay, Raluchuku, thank you. Alright, so the angle between the two vectors is simply equal to what? 90 degrees. 90 degrees. Okay, and that's your solution. Okay, and I'm going to give you an example that for you to do now. Thank you. Thank you. Thank you, Precious. Okay, look at the third example. Okay, in this case, I'm giving you u as I minus 2j. Okay, get onto your book now because you are the one that will do this one. And v is equal to 2I minus j plus 5k. Alright, so find the angle between them. What is the angle between these two vectors? Quickly, everybody. Quickly, everybody. This one will stress you small. Okay, so get onto it. Use your calculator and do it very fast. Of course, it can give you decimal, no problem. Do it very fast, everybody. And meanwhile, I appreciate the involvement of everybody in the class so far. Jessica, Perpetua, Chidinma, Chris, Raulu Chukwublossom, Precious, Confidence, all of you. I've not seen so much of Zikora today. It's like Zik is busy today, no problem. Rita, Diamond, Beke, many of you, Chisom, Ezigwe, yes, Dan, yes, all of you, Ujungwa, you have been very, committed in the class. That's the way to go. So I'm waiting for the answer for this one. So K in V is what? K in V is 5. 5K is 5K. 5K, sorry. 5K. I didn't write it well. 5K. Okay. Okay, Zeke. No, sir, I'm online. Okay, Zeke, you are here. It's just that I've not been seeing your... Anyway, you are doing further today. Okay, no problem. Alright. Meanwhile, please give a thumbs up to this class. So, please go to your this thing and like this particular class. It's important. Also, subscribe to the channel. Please subscribe to the channel. Thank you. Alright. I'm waiting for your response now. Okay. Yeah, Mirabel, I'm seeing your thumbs up. Okay, Raluchuk, you are laughing at Zik. Yeah, you should laugh at him. He ran away and thought I will not catch him. I will catch you. I will catch you. Okay, so any response yet? I know it's going to take a little time, but of course I am waiting. I'm waiting for you. Okay, I'm waiting for you. Okay. Chisom, this 90, is it for the previous example or the one I just gave? Is it for the previous example or the one I just gave? Okay, so, alright, I'm receiving some responses. Precious has something. Okay, Jennifer Phillips, okay, that's okay. Alright. Did I try this? I've not tried it yet, but let me see, okay, if I will get something out of it. Okay. Okay. Precious. Okay. All right. While I'm waiting for you, all of you, can we run through it together because of our time? Let's see. Okay, somebody got 25. Chidera, Precious has 64 point something. Okay, let's run through it. The proof that you have done it is that as I'm talking now, you'll be telling me what to be put in here. So we have, I can go straight and use the formula I already got over there. That's cos theta is equal to u dot v all over magnitude of u times magnitude of v. so I can use this. All right, well, let's go. What did you get as u dot v, everybody? What did Chidima says she has? Is this thing okay? Okay, you have I think, is this the value for your theta? Is this the value for your theta? Okay, so help me. What did you get as your u dot v, everybody? Please respond to me. Let's no, u dot v cannot be 15. What did you get as u dot v? It cannot be 15. Do it well. It can't be 15. I doubt. Yes, I think I've seen the correct answer. U dot v is 19, not 14. It's 19. Okay? How did we get it? The coefficient of, maybe Rita, maybe you are not really seeing this thing very well. Oh, sorry about that. This is I. The coefficient of I here is 1. So our u dot v should be 1 times 2. Then the coefficient of j here is minus 2. And here is minus 1. And then here is 3k. And then k in the second one is 5. So if you multiply this, you should get 2 plus 3 plus 15. Am I correct? Am I correct? 2 plus 2, sorry, don't mind me. 2 plus 2 plus 15, which is 19. Okay, yeah, Chris says 19. That's okay. So what did we get as magnitude of u? Magnitude of u gave us what? That's the square root of 1 squared, which is 1, plus minus 2 squared, which is 4, plus 3 squared, which is 9. That's square root of 14. Okay, square root of 14, okay, times v. What is the magnitude of v? Okay, magnitude of v is equal to square of 2 is 4, square of 1 is 1, square of 5 is 25. So you will get square root of 30. Okay, and that's square root of 30. So this is why I said you can use your calculator. So you have the cos of theta is equal to 19 all over. You can press, where did you see 420? Thank God you have removed it. So you can press square root of what do you call it, of 14. Then that's multiplied by, okay, this calculator is mad though. Let me go to this other one. Okay, all right, somebody said 21 point something. I think that is what is a bit close to what I got. Then let's continue doing it together. Square root of 14, okay, times square root of 30 will give you 20.49 approximately. Okay, and so if you now divide 19 by 20.49, that's going to give you 0.92927. That's to 3 decimal places. And so finally, honestly, the board is always blurred in my phone. Sorry about that. I don't know why it is so. Maybe it's your network. Sorry. Can be cos or inverse of, okay, maybe I should be writing it bigger. Let me try doing that, Rita. Okay, so cos inverse of 0.927. Maybe Rita, you should look at the ones I'm writing now. Is it better for you? Okay, so what is the cos inverse of that? Did anybody get up to this point? Okay, 0.927. Okay, that is giving us remember your answer should be in degrees. That's giving us 25.58. Okay, so this is the exercise. Here you are getting the angle between A and B, and here you are getting the value of u dot v if the length of u and v is 4 and 6, and the angle between them is pi over 3. Meanwhile, pi over 3, you should change it to degrees. You know this pi here in degrees means 180. So that will be 180 over 3, which will be 60 degrees. Okay.